Alright, so we have to determine an advantage of each of the following measures of central tendency. We have the mean, we have the mode, and we have the median. Now, the mean. What is the advantage of the mean? The mean represents all the values in a data set. So in other words, if I have numbers like 4, 10, 12, 16, 32. If I want to find the mean, I will add up all of these numbers and divide it by the total number of numbers that I have here. So it does not exclude any of these values. I would have to include all of these in order to identify the mean. Only time we would be missing some of these numbers would be in a case that we have a trim mean or we're deleting some values, but the mean considers every single value. So that is one advantage of it. Now, the mode. The mode is used to determine the element that occurs the most. Now, one of the advantages of the mode is that you can actually use it for data that is categorized. So for instance, if I have a set of data with colors, so like yellow, pink, green. Which one occurs the most? We have pink occurring the most. So because pink occurs the most, it occurred 3 times, we would say that our mode is pink. It's the most popular option here. So as you can see, the mode can be used for situations where the data is even qualitative and we're using words as opposed to quantities, as in values. So that's one advantage of the mode. It can be used to represent some of the qualitative data as well as categorized to represent the central tendency. Whereas the mean would not be able to do anything with these colors here. Now the median. Now remember, the median is when we organize numbers from lowest to highest. So if we organize numbers from lowest to highest, like in this case here, 4, 10, 12, 16, 32, we would pick the number that falls in the middle. If we are in a situation where there are 2 and we find the mean of those 2, that would represent our medians. Now the thing is about that is that unlike the mean considers all the values. If I find the mean of these values, say for instance, the distance between these, the 32 and the 4, they are far apart. So the larger and larger that some of these get, even the smaller and smaller some of these get, the mean is sensitive to those values because it considers all the values. Now in a case like the median is unaffected by the change in these values. So if I had to do an instance where the values here, instead of having 4, 10, 12, 16, 32, say I had 0, 0, 12, 1000, 1000. The median here, because you have them from lowest to highest, is 12. Now down here, the median here is also 12. So it does not matter what these values here are, the median here is unaffected. Whereas if I was to calculate the mean of the data, the mean for this would be different to the mean for this. So you can check it out just for your kind of, calculation purposes and understanding, but I'm just only using this illustration to show you that the median is unaffected by other values, right? So in this case, we would refer to those random, weird, large or small numbers as outliers. So the median is unaffected by outliers. So this would be one advantage of each of these measures of central tendency. Alright, so as you can see here, this part of the question wants us to determine the central tendencies for this data that we have here. Now the data that we have here is grouped data. How do I know it's grouped? Because the waist size is either equal to or less than 30 but more than 27. So we do not know specifically which value this is, so we would have to use an approximation or estimate of the mean, mode and median. That is why they told us we have to calculate the estimate, because we're not sure what these values actually are in the essence of stuff. Because if we have 4 numbers falling between there, how do you know it's not 4/28? Or how do you know it's not 4/30s? Or how do you know it's not a 28, a 29, a 30, a 30, and a 30? You don't. So as a result of that, we calculate estimated mean, and in order to do that, we have to find a estimate of what the value in here could potentially be. So we would basically find the midpoint, which would be in essence the average of these 2 numbers. So why is the midpoint important? It's just kind of assuming that, hey, if by any chance these numbers that fall between here are a certain value, what if they are just the mean, the average between these 2 numbers? So we would be saying 27 plus 30 divided by 2, which would be 28.5 4.5. Likewise, we do the same thing for this. We have 30 plus 33 divided by 2. So that would give us 31.5. This one would be 33 plus 36 divided by 2, which would give us 34.5. This one here would give us 36 plus 39 divided by 2. Now this is equal to 37.5. And then the last one we have 39 plus 42 divided by 2, which would give us 40.5. So the next thing we're going to do, we're going to multiply the frequency and the midpoint. Now, the reason for doing this is that we're kind of assuming, in this case, that all the values that fall within here would be 28.5. And those values, we're saying that what if there are 4 of those values? So we have 28.5 occurring 4 times. 28.5 plus 28.5 plus 28.5 plus 28.5. And we would do this for the same one down here, 31.5, 14 times, and so forth. Now, the reason we're doing that, we're assuming that each of these values are 28.5, each of this is 31.5, and so on and so forth. So then now when we add up all those values together, we could divide them by the total. So it's just like we're working an average. So we'd have 28.5 times 4, 31.5 times 14, 34.5 times 9, 37.5 times 7, 40.5 times 6. This would give us 114. This would give us 441. This would give us 310.5. This would give us 262.5. This one would give us 243. So now we have to find a total of these. So the total of this here, if we add up all these together, so we add up all of these here for the total. So 4 plus 14 plus 9 plus 7 plus 6. So this would be 40. So right here we have 40 patients that participated. Now it's time to add this up, total of the waist sizes. So we're saying 114 plus 441 plus 310.5 plus 262.5 plus 243. So this is going to give us 1,371. So now to find the estimated mean would be the total of this 1371 divided by 40, which would be equal to 34.275, which is approximately 34.28. And then we have our waist size, which is in inches. Therefore, this here would be inches. So this here is an estimated mean. So we are kind of assuming that the mean would be close to this value here. All of this is for I, the mean. Alright, so for this one, I'll do the estimated median first, and then after we'll do the mode. So with the median, as well as with the mode, when you will see when we do that, we have a formula that we are supposed to use. Now this is a formula that we are given. There are also variations to this formula that considers not the lower limit but the lower boundary. This one considers the lower limit, whereas there are others that consider the lower boundary. Now the ones with the lower boundary would be useful in situations too that we have values like 1 to 5, for instance, as an interval, then 6 to 10. Instead of just using the limit, they would say let's use a boundary. In this case here, the lower boundary is 5.5 and the upper boundary would be 10.5. So then the lower value here would start from the boundary, because that marks the transition from one class to the next class. So this 5.5 would be the lower boundary for that particular class. Nonetheless, if you got that or not, in this particular exam for CAPE, this is the formula that we are more than likely going to be given as it comes in the syllabus, and as a result we need to learn how to use this particular formula. The next thing I would say is that in terms of the frequency of class preceding the median class, this is something that should be actually the cumulative frequency. So that is something that would be nice for them to update, but this would be the cumulative frequency of the classes of the class preceding the median class. So meaning the class that comes before the median class. Okay, so we would have been nice if this had cumulative frequency here. Anyways, let's try to determine these values. So they want us to find the lower limit of the median class. So in order to find the median class, we need to figure out roughly where would the median value be. So if we have 40 people, roughly the median is going to be the middle of that. So somewhere between the 20th person and 21st person. So basically, if we had to do the median, we're using the n plus 1 divided by 2 term. Okay, so we have n is equal to 40 plus 1 divided by 2. That would give us 20.5. So we are looking for basically the value that lies somewhere where the 20th person would be and the 21st. Okay, so this is just helping us to find our median class. Once we find the median class, we use the information from this to answer the question. But the first thing we must do is find the median class. So we would be find the 20th and 21st person. So if we had to do a cumulative frequency, the first person here would be up to 4. This would be 14 plus 4, which is 18. Then 18 plus 9, which is 27. 27 plus 7, 34, and 40. So the first 4 people would be here. First 18 people would be up to this point. So up to this point here, we would have 18. Now just imagine us filling in the gaps. Up to here is the 18th person. So 4, 5, 6, 7, 8, 9, 10 straight up to 18 falls within this area here. Now after the 18th person, where would the 19th person fall? Between here. So the 19th person would be in here, the 20th, 21st, 22nd, straight up until the 27th person. When we go to the next class, the 28th person would be here, then the 29th, and so forth. Now if you look at this, we would have the 20th and 21st person falling in this class here, because once we hit the 19th person straight up until the 27th person, we would be inside of this class here. So this here is our median class, not because it's in the center here, okay, but because the 20th and 21st person would fall within this section here. Remember we said the first 4 people would be here, the first, second, third, 4th person would be in here, then from inside here would be the 5th, 6th, 7th, straight up until the 18th person. Then we come over here, we'll have the 19th person, 20th, 21st, straight up until the 27th. So I know that our 20th and 21st person will fall within this class here. So this here is a median class. So I could say our median class is equal to... Now this is our reference for anything that says median class now in this question. Alright, so it says now L is the lower limit of the median class. So the lower limit here is 33. So we can say that L is equal to 33. Now it says the total frequency. We know that the total frequency N is equal to 40. Okay, now it says the cumulative frequency of the class preceding the median class. So that would be the cumulative frequency, should really at this particular point. So the cumulative frequency of the class preceding the median class, which would be 18. Why 18? Because this is a class right before the median class. So then if that's a preceding class or the class before the median class, we would use the value 18 because that's the cumulative frequency before that particular class. Now frequency 1 would be equal to the frequency of the median class. So the median class in this case is right here, which is 9. Now the width of the class, the width of the median class. So the width of this class would be 36 take away 33. So 36 take away 33, which is 3. Now we have all the values. To work out this median, we're going to use this formula here now. We're going to have the L plus, might as well put it like that, N over 2 minus over times the width. So we have our values already. In essence, not getting too deep into this, but basically this is just a little proportion of the width, and they do it based off of the size of that particular thing, which is 9. So then we have L would be 33 plus N divided by 2. So that would be 40 over 2 minus 18 over frequency 1, which is 9. And that will be multiplied by the width, which is 3. So this would be 33 plus, that's going to be 20, take away 18, 9 times 3. So that would be 33 plus 20 take away 18 is 2 over 9 times 3. So that's going to be 33. 3 into itself goes once, that goes twice. 3 into 9 goes 3 times. So that would be 33 plus 2 thirds. So if we were to put this in our calculator, we'll get 33.67 inches. Once you know how to use a formula for the exam, you'll be good. So the next one we need to do is the mode. All right, so this is the question that we need. So for this particular question, we need to find the mode, estimated mode of the data. All right, so for this particular question, so for this part of the question, we need to find, so for this particular, all right, so for this part of the question, we want to find the mode of the question. So similar to the last question, we have to use a formula. This is a formula that we received from your syllabus. And we said last time that we had an issue with one of these frequencies, but in this one, we're good. The only thing though is with this formula, it should be F0 here. So right here should actually be F0. So hopefully that's adjusted on the actual formula sheet for when an exam is done. If you look anywhere else online, you'll find that this here now is a formula that is often used. Nonetheless, just like we did for the median, we need to find the modal class interval. So what would that be? That would be the class that has the highest frequency. So if you look at this, the highest frequency is 14. So the class with the highest frequency is this class here. When the inches at the diabetic screening of the waist sizes are more than 30 but less than or equal to 33. All right, so now we can look at these values now. So we can say that the L value represents 30, the F1 value, so the frequency of the modal class is 14. We have F0, the frequency of the class preceding the modal class, so the class before the modal class, which would be this one here, which is 4. Now we also have the frequency of a class succeeding the modal class, so the class after the modal class. So the modal class here is 14. The class after that would be this one here, which is 9. And then our width is going to be 33 take away 30, which is equal to 3. Okay, so we have all our values now. We can use our formula. So L plus F1, and remember we say we're using F0 over 2F1 minus F0 minus F2. So just to show you the different formulas that you usually see with this online compared to the little error that we saw here. So we go for the mode of group data. If you just take a quick look at the images, you can see some of the formulas here, right? So we have F1 take away F0 and so forth. Same principle here as well. F1 take away F0. So frequency of the class preceding the modal class. Okay, so this is like the same adjustment that we made. We look at this formula, same concept as well. And if you look at this example here, it's showing us the change in one, which would be 8 minus 7, 7 being the class before that. If you look at this is a different formula written a different way. Fm represents our modal frequency minus F1, the frequency preceding the modal class. We're looking at another formula here, same concept here again. Frequency 1, the class preceding or the one before. So we even have this website that goes into detail explaining how this formula comes about. You can even have a look at this. All right, so let's use this formula now. So we have the mode is equal to 30 plus, this formula looks a bit intimidating, but as you can see, once we have the values, it's not so bad. So then now we'll have 14, which is F1, take away F0, which is 4, over 2 times 14 minus F0, which is 4, minus 9. And all of this would be multiplied to the width, which is 3. So we'll end up with 30 plus, and then we'll have 14 take away 4, which is 10. Then we'll have 2 times 14, which is 28, take away 4, take away 9. So that would essentially equal to 15. So 28 take away 4 is 24, 24 take away 9 is 15. And we are multiplying this to 3. Now, notice here, you could use this on your calculator. I'm only doing this because these are numbers that are easy to go into each other. So 3 can go into itself once, 15. 3 can go into that 5 times. 5 into 10 goes twice. So then we'll have 30 plus 2 times 1, which is basically 30 plus 2, or 32. So therefore, we know that our modal value would be 32 inches. Alright, so just remember what we noticed with the formula. It's always difficult to know what to do in a situation like that. But if I was in an exam, I would always use the formula that was given to me. Even though I may have an issue with it, I may just note it in the exam that, hey, this formula, might have an issue or whatever the case is. So who is ever marking would have a chance to look at it. But that's only in a case where you're confident that that's an issue. Nonetheless, whatever formula you're given, if you're given a formula, try to use it to the best of your ability. And this is why it's important to make sure that you learn how to use these things before an exam to even pick up on something like this. All right, so take note of that. And yes, so in essence, these are our values that measure the central tendency of this particular data that we looked at. So earlier we had to say advantage of these central tendencies. Now we have to do the calculations of them. So this part of the question continues what we were looking at from the previous part. However, in this instance, it's asking us to comment on the shape of the distribution, and then we have to discuss the skewness of the data based on the estimates that we got in the previous question. So what is seen here is actually a histogram with the bars that you see here that was plotted from the data that we saw from the previous question. We also have a frequency polygon on top of that as well too. Now, when we're talking about the shape of the distribution, usually it comes in a few forms. So we usually have one that can be like this. So it has a look that is symmetrical. Now the next one we can have is one like this. So in this case, we would say that it's skewed to the left. So that's how we could describe something like that. It's skewed to the left. What does skew to the left means? It looks like most of the data can be found to the left side. And in a case like this, we actually call this positively skewed. Now the other term, it was like this. This is a negatively skewed, and most of the data can be found on the right. As you can see, this here is what our data looks like. It's something like this, as you can see here. So we can see that most of the data is on this side of the chart. So we could say that based on this, our data is positively skewed, since most of the data is on the lower end of the visual representation. Alright, so the next part says to discuss the skewness of the data based on your estimates of the mean, mode, and median. Just bringing back our values from before here. Since we're commenting based off of these, we have the mean, which is 34.28 inches, the mode, which is 32 inches, the median, which is 33.67 inches. Alright, so based off of this, we need to comment on the skewness of the data. Now, as it relates to the skewness of the data, remember we said that they could be negatively skewed, symmetrical, or it could be positively skewed. Something I like to use to remember the skewness. Now, just imagine this here as a high part was your feet, okay? We'll consider this here to be your whole base of your foot, right? If this was your base of your foot, this would be your thumb, your big toe, then you would have your smaller toes coming down this sides, right? So if you have your big toe here, this here is what foot would this be if you're looking down? This would be your right foot. And if this was your foot coming down, you would have your big toe here, and then we have your smaller toes here. 1, 2, 3, 4. Okay, this is your big toe here. These are your little toes. So what foot would this be? This would be your left foot. Now if I was to think of this as if I was to think of the number line now, when we are going on the right, it's usually what? Positive. So we have here 0, 1, 2, 3, 4, and so forth. And if we're going to the left, or the left foot, we would have -1, -2, -3, and so forth. So that's what I use to remember which one is positively skewed and which one is negatively skewed. If it's positively skewed, I'm trying to think of, okay, which foot would fit inside of this? So inside of this, what foot would have fit here? Well, my right foot would have fit in here if I was trying to put on a shoe here. This would be my right foot. Just like this part here, this would be my right foot. So if that's my right foot, I'm going to say that's positively skewed. Now, if I'm going to fit my left foot in it, I'm going to call it negatively skewed, because the negative skewness is usually on the left side, which would mean that negative skewness looks like this, which means that if I'm thinking of negative numbers, I'm just thinking from the perspective of, oh, negative is on the left of the 0. So that's what I use to remember it. There are many different ways to remember it, but that's how I remember it. Now, when we're talking about the mean, mode, and median as specific values being used to calculate or determine whether it's negatively skewed, symmetrical, or positively skewed, we have to look at the values and compare them to each other. Now, in a perfect situation, when it's symmetrical, the mean would be the same as, or just about the same as, the mode, which would also be the same as the median. So all of them would be equal. Now, in the case of a negatively skewed one, the mode would be somewhere here. So the mode is like the big toe. It's somewhere here. And we would expect the mean to be the smallest value. And then in the center, between the two, we would have the median. It's not going to necessarily be exactly in the center or whatever the case is. When I say the center, I'm just referring to relative to the mean and mode, relative to the value of the mean and the mode. Now, when it comes to positively skewed, again, the mode is like the big toe. So the mode would be on this end. Think of this as our right foot. So the mode is like on our big toe. And the mean would be on the lower end. All right. And just like this one here, the median would also be in the center. So what this means, if we were to think of this on a number line as values, we are thinking of these as values. So what we're saying is the mean would be more than the median in a case of it being positively skewed, and the mean would be more than the median and the mode. The median would be more than the mode but less than the mean, which implies that the mode would be basically the smallest value out of all three central tendencies. Basically, that's what we can use to comment to help us prove that we're going to say that it's positively skewed as well. So I'm just going to sketch this on this and then comment on that, and we'll compare it to which one of these it looks like. So let's look at the mean first. So the mean here would be about 34.28. So this is 30, 31, 32, 33, 34. So 34 is somewhere about here. This would be 34.5. So our value would fall in the center here for the mean. So roughly the mean would be somewhere about here, right? Now, the next one we want to try is the median. So the median here is 33.67. So 33.67. So that's right here. This is 33 right here, and this here is 33.5. So roughly it's going to be just off of that. Okay? So just off of that right here, you would find the median. All right, so the mode now is 32. So this is 30, 31, 32. So right here, we expect to see the mode. So this here is the mode right here. Now, if you look at this and compare it to what we have here, as you can see here, the mode is the smallest value. All right, the median falls in the center, and the mean is the highest value. So we can say that based on our values, the data is positively skewed. Now remember, I just used this to give you a visual representation of what it looks like. But now we have to put it in terms of values. What can we say about the values? So based on our values, the data is positively skewed. This is because the mean is the largest value of the three central tendencies. So that's one. The median falls between the mode and mean respectively, where the mode is the lowest value. Therefore, the data is positively skewed. Okay, so that's basically it. If we had to write it as a formula, we would be saying that mode is less than the median, which is also less than the mean. So based on expressions, this here would represent a positively skewed data set. Okay, so you can also have this as well. So if I was doing this in an exam, I would write it like this, and along with having it written like this, I would also put a diagram to kind of like illustrate my point. Because remember, this is in your answer sheet, so you can actually sketch this on your graph to show relative to each other why they are values that show that the data is indeed positively skewed. In an art competition, the number of paint brushes artists use to paint portraits are examined. The recorded data is as follows. So we have number of brushes here, 1, 2, 3, 4, 5, and we have the frequency 11, 10, 5, 3, 1. We are expected for this to calculate a 10% trim mean and the 40% percentile. Now, in order to figure out the 10% trim mean or the 40% percentile, we need to figure out the total frequency of the data. So the total frequency, we will just add up these values. So 11 plus 10 plus 5 plus 3 plus 1. 11 plus 10 is 21. 21 plus 5 is 26. 26 plus 3, 29 plus 1 is 30. Also remember to do this in your calculator. In the exam, you want to do this in your calculator. All right. Now, it says 10% trim mean. Let's work on a 10% trimmed mean. So when we're doing a trimmed mean, if this is telling us the trim mean, we need to find 10% of this overall value. So it's going to be 10 over 100, which is a 10%. This represents a 10% of 30. So 10% of 30 is actually 3. So what this 3 means is that we have to delete 3 numbers from the upper end of the data and delete 3 numbers from the lower end of the data. So I'll do it from the frequency table. So we have an adjusted frequency table, and I'll actually show you from having the numbers listed out. So if we were to take off 3 values from the top and 3 values from the bottom, then we would have a adjusted frequency as follows. If we were to remove 3 from the first values, we would only be left with 8 in this frequency. All right, and if we were to take out 3 from this bottom one, we would have to eliminate this, so we won't have this here, and from this here we have to take out the remaining 2. So we already took out that 1, but it doesn't have enough to deduct the full 3, so we have to minus the rest 2 from here. So in up here we minus the 3, here we minus 2, minus 1, so then we will minus 3 from both ends. So then we'll be left with 8 here, and in this case we will be left with 1, 5, and we'll have 10 here. Now, just in case you did not visualize that, I'll actually list out the numbers so you can see. So we have 11 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I have 10 twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 twos. Now 5 threes, 2, 3, 4, 5, and then we have 3 fours, 1, 2, 3, and we have 1 5. So remember we said we have to find a 10% trim mean, which would mean that we will eliminate 3 since it represents 10% of 30 from both ends. So if I eliminate the 3, we'll have the 3 ones at the top gone and the last 3 digits here gone. So if you look at this, we'll be left with 1, 2, 3, 4, 5, 6, 7, 8 ones. We still have our 10 twos, we still have our 5 threes, and we just have 1 4. Okay, so 1 4, 0 5s now. Okay, 1 4, and this 8 here was adjusted, right? So we have a new frequency, which is 24. Now this is very important. This here is very important because when we're finding the mean now, we have to divide by 24 because this is a new total number of values. It's not gonna be 30, so we don't even want to be thinking about 30. So what we can do is add up all these values here, and then once we add up those values, we divide them by 24. Likewise, to make life easier for us, we know that we have 8 ones. So then we know we'll be saying 1 times 8 is equal to 8. We have the 2 10s still, so 2 times 10, that would be equal to 20. We have 3 5 still, so that's going to be 3 times 5, which is 15. We have 1 4 now. Okay, remember we have 1 4 now. That's our adjusted value. So we have 4 times 1, which is 4. We do not have 5s anymore, so we have 0 5s. So now when we add these all up together, we get a total of 47. So our total here is 47 based on our adjusted value for the trim mean. So we have 47, which now we have to divide by the total number of inputs. In this case, if you count all of these, we have 24. Add these up, we have 24. So then it's going to be 47 divided by 24. So that's just going to be under 2. So the value is 1.9583. So we could approximately say to 2 decimal places, it's 1.96, and the unit would be brushes. Okay, so 1.96 brushes. Since it's discrete, we can't have a 0.96 of a brush, so we could just say roughly this would be 2 brushes. Okay, so roughly this is what we're gonna consider this to be. All right, so this is our answer for this part of the question. Okay, so we just got that. Now our last one is the 40% percentile. So when we're talking about percentiles, if we want a 40th percentile, we'll have to say 40 over 100, and this would be multiplied by n plus 1. There are many variations to this question and many different formulas used. So based on whatever formula you use, you have to be marked on. If a formula is provided, then in that case you have to use the formula provided. But if you use this formula, which is one of the formulas used, or if you use it by itself, which is just a 40 over 100 times n, whichever one is used will determine what your answer is. Now this one here, this particular formula considers inclusive of the value that's the 40th, right? Whereas this formula looks for those exclusives. So in other words, whatever value comes here, 40% of the data is under this value. So for instance, if the value was to say be, let's just use in our case, let's just say under 2. So any value under 2 would represent 40% of the data. Now for this formula, what it would be telling us is that if it's 2, it's including the 2 as well. So this specific 2 and all the values underneath that 2. Whereas for this one, it's saying that we are not including this 2, but we're talking about the values that are under this particular 2. And then there are different methods that we use when we actually find this, and so forth and so on, right? But for this particular case, we're going to use it. So 40 over 100 times n plus 1, it's going to be this times 30 plus 1. So it's going to be 40 over 100 times 31. Now when we put that in the calculator, we're going to get 12.4. So what this formula means, we're looking for the 12.4th term. Now the 12.4th term would fall between the 12th number and the 13th number, right? Somewhere between those two numbers. So in this case, we have our first number, second number, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13th. So we're looking at a value that falls somewhere between these two here. This is our values of focus. Now, if we did it from the frequency, we know that this is up to 11. So the first 11 values are here. So that means the 12th, the 13th, 14th, etc. would be in this, etc. will be in this particular situation here, which would be 2 as well. Okay, so we're looking at the 12th and 13th. So it's obvious based on this answer that our 40 percentile is actually gonna be equal to 2. So just to walk it out how we would have walked it out if the values were different. So using this 12.4th term, what we would do is we look at the 12th term, which is a 2. So the 12th term is a 2. Right here, 12th term. So you'll have the 12th term being the number 2, and we're going to add to that. Now you see the 0.4, we're going to find 0.4 of the difference between the 13th and the 12th. So we'd say 13 take away 12. In this case would be 2, because the 13 is 2, take away 2. So 2 take away 2 is 0. So then we'll end up with 2 plus 0.4 times the difference, which is 0. And that will give us 2 plus 0, which is 2. So that's one method of doing it. Next method would have just found the average of the 2. So then we will say 2 plus 2 divided by 2, which is what? 4 over 2, which is equal to 2. So this is the area in statistics that we have different perspective on different things. This does it by trying to distribute it based on the difference. This one just says, hey, forget about that. Let's just find the average between the two values since it falls in the center. But in our case, every single option that we have gives us 2. Even if we did the first formula that was inclusive of, which would have been the 40 over 100 times the n. So if we had the n being 30, so 40 over 100 times 30, we would have had 12. And with that 12th value, we would have ended up with 2. So even in this case, it would have been 2. So all our perspectives, no matter how we answer this question, our answer would have been 2 for this particular question, which is good. All right, so hopefully this helps. So continue looking at these videos, continue studying, keep it up, don't give up, continuously keep going over the work. Practice and understanding the deeper reason behind things would assist you in growing in this subject and getting better at what you do. Make the best out of this opportunity while the opportunity is alive. So continue to work hard, don't give up. All the best in your exam. Be smart.